This lesson will focus on the last piece of looking at data and analyzing data and trying to figure out a model that represents the relationship between variables. Today we're going to talk about mathematical modeling, which now takes a graph that shows the relationship between variables and now fits an equation to those variables in that graph that now represents that relationship. So up to this point, we should now be able to look at all these objectives, and you should be able to do at least the first three, and after this lesson, do the last one. We started by talking about taking data from a experiment and then graphing that data properly, looking at the rules of graphing. And then we talked in the last couple lessons about looking at a graph and then determining a relationship. And the last lesson we focused on graphical modeling, on taking a graph that shows a relationship and being able to get a direct relationship from that. Now what we're going to do today is now relate that graphical model to a mathematical model by fitting an equation to that relationship that shows now a mathematical relationship or model between those variables that we can then use in a more general sense. So with graphical modeling and mathematical modeling, what we're going to do is a process called curve fitting. And we kind of introduced this in the last lesson on graphical modeling. Curve fitting is a process that matches a mathematical equation to a curve. So last lesson we looked at being able to look at a graph of two variables and being able to determine a graphical relationship between them. Now with curve fitting, what we're going to do is take that graphical relationship and now fit an equation to that. Think of like a graph, you may have done this before, something called putting like a linear fit onto it or matching a curve to that. That's exactly what we're going to do. But now we're going to actually express that curve in terms of a mathematical equation. And then we're going to actually use that equation in a more general sense by plugging in variables to get some sort of output. Alright, the key thing here is that when doing curve fitting, what we're always trying to get is the simplest relationship in physics, which is a direct relationship. And again, to review this from the last lesson, a direct relationship is one in which, looking at the variables, you see that when you graph x versus y, you see that they have the same effect on each other. So increasing the x would cause an increase in the y. Right? And this linear relationship or direct relationship is the one that we are always going to try and achieve, because when we get this relationship, we can express this relationship mathematically by following the equation y equals mx plus b. And this is the simplest equation that we can formulate in physics, in, I guess, any graph, that will allow us to express that relationship. So again, just kind of going and reviewing what is a direct relationship. We said a direct relationship shows that when you change the independent variable x, it's going to cause the same effect on the y, such as increasing the x would increase the y. And we said that we always want this relationship because it really is the simplest relationship we could have graphically. And it's also one that we can write an equation simply by following the form, the slope-intercept form y equals mx plus b. Looking at this equation, this is a simple expression for us to relate these variables. Right? It's not a complicated equation, and we can look at this equation, we can draw certain information from it. And some of the more important variables that we can find is m and b. Okay, so from math, this is a little bit of a review. What do these two variables represent? Okay, well, looking at m represents something called the slope of a graph. Okay, and the slope, many of you have probably heard of this, rise over run. Well, what we'll find is really a change in y over change in x. So the importance of the slope is that it shows the relationship between the change in the dependent variable as a result as a change in the independent variable. Okay, again, the dependent is the y and independent is the x. And b represents something called the y-intercept. The y-intercept, when represented on the graph, is shown where when x equals 0, y is going to equal some value. Okay? And on the graph, this is shown where the line or your curve intersects intercepts the y-axis, hence the y-intercept. Okay? Now, we'll talk more about what the importance of this y-intercept represents, but if you think of a graph, okay, when x equals 0, so when our independent variable is equal to 0, y has some value. So if you think about what that means in terms of a relationship, our independent variable, we have done no change to it, and yet we have some initial y value. Okay? So usually it's talking about some sort of initial value that we may have with our dependent variable. So why we get a direct relationship is because we can draw a lot of information between the slope and the y-intercept. Slope and y-intercept are going to be very important things when looking at graphs and determining that mathematical relationship. And in the equation y equals mx plus b, y and x simply represent our variables. So we are expressing a relationship between our independent and dependent variable and have two values, the slope and y-intercept, that we are able to then draw some meaning from. So that's why it's so important to get a direct relationship, because we're relating our variables and we're also drawing in some other information. Okay, up to this point we went through how to actually graph data. Then we talked about how to take data and determine, or take a graph and determine the relationship from that graph, and then being able to modify the data, i.e. modify the independent variable such that we get a direct relationship. The next step and very last step that we're going to do is actually take that direct relationship, and we're now going to write the mathematical expression or the equation that represents that relationship. So when writing our equation from that graph, from that direct relationship graph, there's a certain amount of, or certain steps you're going to follow. Okay, the first step, and we talked a bit about this in the last slide, is that we're going to calculate both the slope and the y-intercept. Okay, now when graphing by hand, calculating the slope and y-intercept is something that you're going to have to do by hand. When we get to actually graphing on the computers, these things will normally be given to you, so you can basically take it right from that graph. Alright, but the first thing really is to calculate the slope and calculate the y-intercept. And again, those two pieces of information are going to give us information about those variables that we're looking at. Then what we're going to do is we're going to write, then once we know the slope and y-intercept, is we're going to write the equation in the form of y equals mx plus b. This equation represents a direct relationship. And then what we're going to do, the last thing, is looking at y and x. Those, remember, y represents our dependent variable and x represents the independent variable. We are then going to rewrite our equation that's in the form of y equals mx plus b, but instead of writing y and x, we are going to replace these two variables with the variables that we have shown on our graph. So we are actually going to express it in the variables that we are talking about, instead of just writing it in a general sense of y and x. What is y, what is x, and we're going to put that into the equation. And then the last thing is we're going to include units on both the slope and y-intercept. The reason why we include units is because when looking at the units on the slope and y-intercept, that is where we're going to draw meaning. Okay? You can easily, if I were to ask you what is the meaning of the slope, by looking at the units, you should be able to tell what is that relationship. What does the slope mean? Same thing with the y-intercept. What are the units on the y-intercept? What does that mean? Okay, so that's the very last thing we'll do. Before we actually get into an example of writing a mathematical equation, let's take a second just to simply review how we can actually calculate a slope and a y-intercept, because this is the very first step in determining your mathematical equation that represents that data. Alright, so the slope, again, the slope, one of the main things that people know is the term rise over run. Okay, well, what does rise over run mean? Well, if you think of a graph, the rise usually represents your y value, and the run usually represents your x. So when looking at the rise over the run, the slope is really talking about the change in your y value divided by the change in your x value. It's comparing both the dependent and independent variables and how they change. So when calculating the slope, we're going to look at the change in y over change in x. Now, this is something we're going to see very often. This the symbol delta, the triangle delta, is a mathematical expression that means change in. Okay? And change in always represents your final data point minus your initial data point. So it's always final minus initial. By looking at final minus initial, we can then calculate a change in. So when I talk about your change in y over change in x, or your rise over run, we're looking at your final y, shown as y2, minus your initial y variable, which is y1, divided by your change in x, which is your final x variable, or independent variable, minus your initial x variable. Looking at those two values, when you subtract, you're going to get a change in y over change in x, and then you're going to be able to take that and just divide them and get a decimal, and then we're going to use that as our slope. So that's how we calculate the slope. And then the y-intercept. Okay, the y-intercept, again, in this equation, y equals mx plus b, is b. Now, if we don't know the y-intercept, if we can't directly see from a graph that it's some value, either 0 or some value that we can just directly see from a graph, we're going to have to calculate it. So how do we calculate it? Well, this follows calculating the slope. Once we have the slope already calculated, so we calculated m from up here. Okay, what we can then do is choose any point on our data table. Choose any point. Say I want to choose my first point. And what I'm going to do is I'm going to plug into my y equals mx plus b formula, and I'm going to plug in my x value and my y value, and then what I would have is I'd have y1, I'd have m, and I'd have x1, and that leaves me the only thing I don't know is the y-intercept b, which I can then calculate. And then all you got to do is perform some algebra, and you can solve for b. Okay, so when we actually write an equation, the first thing again you're going to need to do is calculate the slope and y-intercept. So if this still confuses you, make sure you go back and take a look, maybe kind of refresh your mind on how you actually do this from a graph. Alright, now before we actually go into the whole process, we're going to put everything together in this next example. Before we do that, let's try just simply writing the equation the way we want to. Alright, now here's a data set from your worksheet looking at this weight in pounds versus A in months. So I'm guessing A would represent some sort of age or time or something like that in months. Okay, so really I think it's looking at weight versus age. All right. So looking at this relationship, if you were to graph this data and looking at, okay, what is the relationship between this graph? Well, you see that the points increase. Okay, as the age and month increases, the weight also tends to increase. All right, and you can tell from this graph that you are getting, if I were to interpolate the data points with a smooth line, I'm going to get a direct relationship. Okay, so this graph right away is a direct relationship between these two variables. Once I know it's a direct relationship, the next step then is to represent that relationship with a expression, a mathematical expression. In any direct relationship, we are going to express this in the form of y equals mx plus b. So this is practicing and writing the mathematical expression, or the equation. Now, I gave you in the last slide a couple steps you're going to do. So, the first step we need to do is calculate both the slope and the y-intercept. So let's start by calculating the slope first. Okay? Now, when calculating the slope, I'm going to do this up here. The slope, again, is your rise over run, or your change in y over change in x. So you're going to take your y2 and y1 and your x2 and x1. Now, what is it y2 and y1 and x2 and x1? Well, what I'm going to do, the best way to choose your slope is I'm going to choose the first point and the last point to represent my data. Okay? This is going to be point 2 and this is going to be point 1. Now, if we look at these points, point 2, if I were to look at it in terms, and I want to write it in terms of x and y, okay, my x variable is at 8. We're at 8 months. And my y, if I were to go across here, okay, is about at 17. I'm going to put that at 17 just to make it a nice even number. Okay, so I got the point of, I'm at 8 months and 17 pounds. In point 1, if I were to do this one, we are at about 1 month, and we're at about here, if I were to move that over, it would be about 7 pounds. So I have these 2 points. So to calculate the slope, what I'm going to do is I'm going to take my y values. I'm going to take, again, y2 minus y1 over x2 minus x1. So my y2 value, my second y value is 17. That's shown here. Minus my first y value, which is 7. Divided by x2 minus x1. So x2 was 8. x1 was 1. So now taking that math, I'm going to get 17 minus 7, which is 10, divided by 8 minus 1, which is 7. Okay, and this value represents the slope. So the next step then, if you want, that's a fraction, so let's put that into a decimal. Plugging this into your calculator as a decimal, you'd get about 1.43 as your slope. Alright, so there's my slope. So m equals 1.43. Next step then is to find the y-intercept. So I'm just going to circle this here. My y-intercept, now what I do is I choose any point. And I'm going to plug it all into this equation here. Okay, so I'm going to choose the first point, where y is equal to 7 and x is equal to 1. And I'm going to plug it at this point into that equation. So I'm going to get 7 equals m. Well, that's my slope. I just calculated it. Is 1.43 times x, which is 1, plus b. And now you can see it's a simple algebra equation where I can solve then for b. So solving for b would be 1.43 times 1. And to get b by itself, I want to subtract this over, which would just be 1.43. And that's going to give me b. And b is going to equal 5.57. Okay, so I've now calculated m and b. Now the next step, once you have the slope and the y-intercept, is now to write your equation in the form of y equals mx plus b. So I'm going to plug it in. I'm going to do this over here. So y equals my slope of 1.43 times x plus b, which is 5.57. Oops. Let me erase that. Plus 5.57. Okay, and if you look at this relationship, it doesn't match the graph. Well, if I were to extend this line, if I were to extrapolate, I would be hitting something around 6. So I'm getting pretty close to what it actually would represent. And the slope is showing that it's equal to 1.43. Okay, now the next step then was to rewrite, instead of writing my variables y and x, I want this equation to actually represent what is shown on the graph. So I want to draw physical meaning from this graph. So I'm going to next replace, instead of writing y and x, I'm going to replace them with my actual variables. So remember, y represents your dependent variable shown on the y-axis. So instead of writing y, what I'm going to write is weight. So I'm going to write w in terms of weight equals 1.43 times x. And x is equal to a, which is talking about age, plus 5.57. So there's my new equation. It says weight equals 1.43 times age plus 5.57. Okay, so now I have it written in terms of my variables. And now the very last step, if we want to draw some information from this, most likely the information is coming from the slope and the y-intercept. And where I draw meaning is from the units. So what I'm going to next do, the very last thing, is I'm going to rewrite this equation, and I'm going to include the units on the slope and y-intercept. So I have weight equals 1.43. Now what are my units on the slope? Well, the slope is equal to your y over x. So in order to find the units of the slope, I need to first know what are the units on my y. My y is written in terms of pounds. Okay, divided by x. My x is represented in terms of months. Okay, so what I have in the units of my slope are pounds per month. Okay, so I have 1.43 pounds per month times the age, still has my x variable here, okay, plus 5.57, and then what are the units on my y-intercept? Well, again, the y-intercept is the point at which x is equal to 0 and y is going to have some value. So your y-intercept is simply a point of y. There is no x value, so it's just y. So your y-intercept always has the same units as your dependent variable or your y variable. So in this case, I'd have 5.57 pounds. And here now is my final equation. This is my mathematical relationship. Okay, now let's look at what this means. It's telling me that the weight in pounds is equal to 1.43 pounds per month times the age plus 5.57 pounds. So what does this mean? Well, if I look to start at the slope, for example, is where we draw meaning. 1.43 pounds per month. So this is telling me that every month, for every 1 month, pounds per month, for every 1 month, I'm going to gain, or whatever this object is going to gain 1.43 pounds. If I multiply that by any number, any sort of month, right, that's going to tell me whatever that weight is after a certain amount of months. So the slope is telling me how much weight I'm going to gain in a certain amount of time. Okay? And then the next formula, 5.57 pounds. It's representing weight. So this is telling me that when x is equal to 0, so when I am at an age of 0, so whatever this thing was just born, it weighed 5.57 pounds. So it's telling you your initial weight. Okay? So if this equation, let's say we're talking about babies, this equation would be known as the baby formula. Okay? It's amazing how we can take a graph, find an equation, and now this equation now represents something physical, something in real life. Okay? It relates things that actually happen, weight in pounds in terms of age. So notice how we are taking a graph, drawing a relationship from it, and now actually writing that in the form of an equation, such that I can plug in any age there, and it'll tell me the weight of that baby. And this is really the whole point of mathematical modeling, okay, is that we are going to take a graph, draw a relationship from it, get a direct relationship, and then actually express that relationship in terms of an equation.